Career Connections.
My name is Jack Moore. I'm a welding engineer at Yaskawa Motoman, and we make industrial robots. They're very durable. They can go to the same point over and over and over within like less than a millimeter. They're very accurate, and it's all about doing the thing over and over and over and over and over. We can go to the same point every time. We can go through the same path every time. So they're industrialized. They can take fumes. They can take impacts. They can take all types of damage that's caused by the process. I've got a bachelor's in science from Ohio State Welding Engineering program. When you go into college, you can specialize in a certain few things, and I specialized in weld metallurgy as well as robotics. So it's typically, we're welding steel, we're welding aluminum, a little bit of stainless steel, a little bit of copper. All those materials have different physical behaviors that are different from each other. With welding in general, what we're trying to do is we're trying to melt two pieces of metal together. What we do is we pass typically some sort of electricity through it. When you pass electricity through metal, that heats up. We pass a lot of electricity through, it heats up so much that it can turn from solid to liquid. So now we have two pieces of metal, this turns to liquid, this turns to liquid. That liquid mixes together into a common weld pool, and then we remove the heat source, we remove the electricity, and now that cools, it freezes, and now we have a solid structure.
Oh, so this is super cool. This looks totally different than the other robots. It's on a huge monster track. And I also noticed like this big, really big motor right here. Tell me about this thing.
That's right. So we make small robots, medium-sized robots, and this is one of the bigger robots that we have. Most of our robots have 6 motors, 6 axes. So there's an axis here, axis here, axis here. You'll see 3 motors here. There's 4, there's 5, there's 6. So there's your 6 motors for the robot. So you can see the robot doesn't have any feet, it doesn't have any wheels. So we add this 7th motor, and this is a track, so it allows the robot to slide up and down the track, increasing its range of motion. So that's our industrial robot. That's the blue robot. So we typically don't have people work next to them. So Motoman, what we do is we'll actually design systems around the robot to keep people away from the robot so that people can't get injured by the robot. Now we have a white robot, and the white robot is a collaborative robot. And that robot allows us to take the walls down. So I'm working close to the robot, and if I'd like the robot to stop, I can press on the robot, it'll stop, and then I can have it resume. Continues on. So I can work next to it, I can interact with the parts. Robot, why don't you stop for a second? I'm gonna do something else. Robot, you can resume. So now that people can get right next to the robot and they can interact with the robot. So maybe the robot's holding a part, and then somebody comes in and touches the part, they do some work, they slide some things in, and then they walk away and the robot does more things. They can work together now. We get a bare robot from our parent company in Japan. Bare robot, it's just a blue arm, nothing attached to it. So one of the things we do here as an integrator is not only do we wrap the robot into a safety system, but we attach tools to the robot. So it could be a gripper, it could be like a glue gun, it could be a painting, a paint sprayer, or it could be like a welding torch. And then an accessory to the welding torch might be a vision system, like an eye that we attach to the robot. Or maybe with that welding torch, we use the welding torch as a finger to touch the part. So we have to have, there's a whole software side to allow those tools to work. And that's the kind of the software development, the coding that I do. So I'm always developing that code to make it easier for our customers to grab that pendant and just really easily, quickly learn how to drive the robot. You can learn how to drive the robot, I can teach you in 5 minutes, right? And a lot of that is because of software in the background making that easier. So here's the buttons we use to drive the robot in the different directions.
Okay.
What's unique about this pendant is you can drive the robot based on, normally we say X, Y, Z, so X is always that direction, Y is always that direction. With this pendant, based on wherever you tell it, you can say go forward, go forward, go forward.
So now if I turn this way,
exactly.
Forward is forward,
Yeah.
left is left, and when I turn this way,
So how much easier is that now, right?
that's so much easier. I don't have to know my XYZ axes, and it's not in relationship to where it was. In fact, I can just manage this, and if I'm working and I need to come over here, I can go to the right and it goes to the right. Oh, that's really cool. Yeah, that user interface is super awesome.
My favorite thing to work with is laser sensors. It's an eye for the robot, right? So robots are blind. Robots can't see, they're not aware of their environment. And so we can attach a laser eye to the robot, and now it can see things that it couldn't see before. So now we can have the robot kind of do some magic things, right? So now it can not only see like where the weld seam is, but like what it is. Maybe there's a gap that's opening and closing, right? So we can do like the robot can be smart, can be intelligent. Every time we give it the same part, but the parts are changing a little bit, it can react to that, it can adapt.